Hello everyone, myself Hans. Today we are going to solve the given problem. Here in the question, solve x into x square plus 3y square into p minus of y bracket 3x square plus of y square into q is equal to 2z bracket y square minus x square. We can solve the given problem with the help of Lagrange differential equation. Given equation is this is given by x into x square plus of 3y square into p minus of y into 3x square plus of y square into q is equal to 2z y square minus of x square. Comparing the above equation with comparing above equation with pp plus qq is equal to r form, and from here we get p is equal to this is x into x square plus of 3y square and q is equal to minus of y into 3x square plus of y square and r is equal to this is given by 2z into y square minus of x square. We have to write the write Lagrange auxiliary equation. This is given by dx upon p is equal to dy upon q is equal to dz upon r, and we have to put the given value pqr here. This is given by dx upon the value of p is x into x square plus of 3y square, and the value of q is given by minus of y into 3x square plus of y square, and dz upon the value of r is given by 2z into y square minus of x square. Let this equation 1, and this is the first, second, and this is like third. We have to take a first multiplier. We choose a multiplier to take a denominators becomes 0, so we have to choose a multiplier taking multiplier is 1 by x and 1 by y and 1 upon minus z for each ratio. So we have to find here, this is given by 1 by x dx upon x square plus of 3y square into 1 upon x square, and here is minus is on minus is already present, so I have to write here minus, and this is given by once again plus of dy for dy, this is 1 upon y dy, and for dz this is given by 1 upon of minus z dz, and from here we can also write this is minus of y into 3x square plus of y square into, here is multiplier is 1 by y, and for the z this is given by 2z into y square minus of x square, and the multiplier is 1 upon minus of z, and we have to solve here. From here this is x square, 2x is cancelled out, remaining is x, and once again multiplier is 1 by x, so we have to cancel out 1 by x, 2 by x is cancelled out, and from here y to y is also cancelled out, and we can also cancel out the z to z cancel out, and further we have to solve. This is given by 1 by x, 1 by x into dx plus of 1 by y into dy, and minus of 1 by z into dz upon simplification for denominator. We get here this is x square plus of 3y square, and from here this is minus of 3x square and minus of y square, and here is plus of 2y square and minus of 2x square. Solving, we get here x is plus of x square, and once again here we have to take 1 minus 1 upon z is a multiplier, so we have to here minus 1 multiplying, this is minus of 2y square, and this is plus of 2x square. Here is 1 upon minus z is taken as a multiplier, and we have to solve. This is x square and plus of 2x square. This is 3x square plus of 3x square and minus of 3x square is cancelled out, and plus of 3y square and minus of y square and minus of 2y square. This is minus of 3y square and plus of 3y square is also cancelled out, and the remaining is 1 upon x dx plus of 1 upon y dy minus of 1 upon z dz, and here is denominator is 0, so we have to write here 0, and further we have to integrate here. This is given by dx upon x is log x and dy upon y is log y, and here is dz upon z is minus of log z, and taking constant as a log c1, and from here we have to use the property of log. This is given by log mn is equal to log of m plus log of n, and we can also know that log m upon n is given by log m minus of log n. So I have to use here is log m plus n, so we have to write log mn. This is written as log xy minus of log z is equal to log of c1, and from here again using the log m minus n, we can also write log m upon n. This is given by log xy upon z is equal to log of c1, and from here we have to write xy upon z is equal to c1. Further we have to solve. Further we have to solve taking, this is first part, taking first and second ratio, first and second, so we have to write here dx upon x into x square plus of 3y square, and dy is equal to minus of y into 3x square plus of y square, and we have to solve this. We can write the value of c1 here. We have to calculate, this is xy upon z is equal to c1. Further we have to use and write the final answer, and we have to solve this first and second ratio. This is given by, first we have to convert in the form of taking dx in the denominator of dy. This is given by dy upon dx, and minus of y into 3x square plus of y square is taking numerator of x into x square plus 3y square. So we have to write here, this is minus of y 3x square plus of y square upon, here is x into x square plus of 3y square, and we have to convert the given differential equation in the form of the homogeneous. This is written as, we have to write, this is minus of y by x, y upon x, and from here we can also write, this is 3 plus of y upon x का whole square. This is y upon x का whole square upon, here is, we can also write, this is 1 plus of y upon x का whole square. When we solve, this is given by y square upon x square, taking LCM here, this is x square plus 3y square, here is 3y square, once 3x square 3y square, here is 3y upon, once again here is 3x square plus of 3y square. So we have to write here, this is 3 plus of y upon x square, and we can also write here, this is the form, this is written as, once again, we can also write here, this is 1 plus of 3 into y upon x का whole square. When we have to solve, this is what 3y square upon x square, taking LCM here, this is x square plus 3y square, and we can also from here, this is 3x square plus of y square, and x square to cancel out, and further we have to let, this is the form of homogeneous, so we have to let here y is equal to nu x, and differentiating with respect to x is given as v plus x dv upon dx, and from here this is given by y by x is equal to v. So we have to put in place of y by x, we have to put nu here, this is given by, and in place of dy by dx, this is written as, this is dy upon dx. We can also write v plus of x dv upon dx. So we have to write v plus of x dv upon dx is equal to, here we have to put y upon x is v, so we have to write here minus of v into 3 plus of, in place of y by x we have to write v, so we have to write here v square upon, this is 1 plus of 3 v square, 1 plus of 3 v square, once again v square v plus x dv by dx, and this is, and further we have to solve, this is given by x dv upon dx, and plus of v is taken to right hand side, this is given by minus of v into 3 plus of v square upon 1 plus of 3v square, and v is taken to right hand side, this is given by minus of v, and from here we have to take common, v is taking common, minus v is taking common once again, and the remaining is here, this is given by 3 plus of v square upon 1 plus of 3v square and plus of 1, and further we have to solve. This is given by x dv upon dx is equal to minus of v, and here we have to take LCM here, this is given by 3 plus of v square and 1 plus of 3v square upon 1 plus of 3v square, and further we have to solve. This is given by x dv upon dx is equal to minus of v, and from here 3v square plus of v square, this is given by 4v square, and 3 plus 1 is 4 upon, this is 1 plus of 3v square, and further we have to solve. Take a common 4 from here, this is given by x dv upon dx is equal to, from numerator we have to take common 4, this is given by minus of 4 and 1 plus of 4v, v is already present here, once again this is minus of 4v, and this is remaining 1 plus of v square upon 1 plus of 3v square, and further we have to arrange the differential equation. We have to arrange the differential equation in the form of, this is taking dx is here, and this is written as minus of, once again we have to, here is dv and v into 1 plus of v square is taken to numerator of dv, this is written as v into 1 plus of v square, and 1 plus of 3v square is taken to numerator of dv, this is written as, once again we can write here 1 plus of 3v square into dv is equal to, and here is remaining minus of 4, and dx is cross multiplication, this is equal to minus of 4 dx, and x is taken to denominator of, this is x, and further we have to solve. 1 plus of 3v square, we can also write here 1 plus of 3v square in the form of 1 plus of v square plus of 2v square upon v into 1 plus of v square. Here we can write 1 plus of 3v square in the form of 1 plus of v square plus of 2v square, and is equal to minus of 4 dx upon x, and further we have to take 1 plus of v square in 1 plus of v square upon v into 1 plus of v square, and plus of 2v square upon v into 1 plus of v square, and here is whole dv is equal to minus of 4 dx upon x, and further we have to solve. We can also write here, this is 1 plus of v square to 1 plus of v square is cancelled out, and from here v to v is cancelled out, remaining is v. So from here this is 1 upon v and dv, and this is plus of 2v upon 1 plus of v square into dv, and minus of 4 dx upon x is taken, 4 dx upon x is taken to left hand side, this is plus of 4 dx upon x is equal to 0, and we have to integrate both the sides. integrating both the sides, integrating both the sides, we get this is dv upon v is log v, and plus of here we have to let suppose 1 plus of v square is t here, 1 plus of v square is t, so we have to write here 2v is equal to dv is equal to dt, and we have to remove here dv, this is given by dv upon dt upon 2v, and in place of we have to write dv in place of dt upon 2v, and 2v to 2v is cancel out, and here is 1 upon t, dt upon t is on integrating log t, so we have to write here directly log 1 plus of v square, and here plus of 4 log x, and we have to take an integrating constant, this is log c2. Log c2. Now we have to write here log c dash, and further we have to use the property of log. We can also write this is log v plus of log 1 plus of v square, and we can using the property, this is written as log of x to the power 4 and log of c dash, and further we have to write using the property of log m into n, m plus n written as log mn, so we have to write here log v into 1 plus of v square into x to the power of 4 is equal to log c dash, and from here log to log is removed, this is written as v into 1 plus of v square into x to the power 4 is equal to log of c1 dash, and we have to put the value of v here. We have to let earlier y is equal to new x, and so we have to put the value of new, this is given by y upon x, and we have to put here this is given by y upon x into 1 plus of y square upon x square, and here x to the power 4 is already present, and this is given by, once again log to log is removed, here is c dash, only c dash, and further we have to solve taking LCM here, this is given by y upon x into x square plus of y square upon x square into x to the power 4 is equal to c dash, and from here this is x square into x, this is x cube, this is cancel out, the remaining is x here, so we have to write here xy into x square plus of y square is equal to c dash, and we have to earlier find here xy upon z is equal to c1, and so we have to put the value of xy from here, this is given by c1z, so we have to put here in place of xy, this is given by c1z into x square plus of y square is equal to c dash, and further we have to find the value of z from here, this is given by z into x square plus of y square is equal to c1 upon c dash upon, once again c dash upon c1, and we have to let constant here, this is given by z into x square plus of y square is equal to c2, and this is given by taken c dash upon c1 is c2, we have to replace, and we have to write the final answer, this is given by phi of c1 dot comma c2 is equal to 0, and so we have to write here phi, and the value of c1 is x1 upon z, and the c2 is z into x square plus of y square. This is the required solution of the given problem. Thank you class and thank you for watching. This is the important problem for Lagrange differential equation.